Hello everyone, this is Hussein and you are here at the Bloomberg Educare. So today we'll learn about some of the basic terms about the structure of atom. We will know what an atomic number is, what is mass number, what is an electron, what's a proton, what's a neutron. We will also learn about some of the terms like the isotopes and isobars and isotones. So let's start with the atomic number. The number of protons present in the nucleus of an atom is known as atomic number. The number of electrons in an atom is also equal to the atomic number. It's denoted by an alphabet Z. The atomic number is always equal to the number of protons or electrons in the nucleus of an atom. So in simpler terms we can say that atomic number, that is Z, is always equal to the number of protons or the number of electrons. Now let's see what a mass number is. The sum of the number of protons and neutrons present in the nucleus of an atom is called as the mass number. It is denoted by an alphabet A, and in simpler terms we can say that mass number is always equal to the number of protons plus the number of neutrons. Now let's have a look at the composition of an atom. So atom basically contains electrons, protons and neutrons. So what's an electron? Electron is a fundamental particle present in an atom which carries one unit negative charge and has a negligible mass. The actual mass of an electron is around 9.1 into 10 to the power minus 31 kg, which is approximately equal to 1 by 1837th of the mass of an atom of hydrogen. So the electron carries a charge of around 1.6 into 10 to the power minus 19 coulombs. Similarly, let's see what a proton is. So proton is the lightest particle of the matter possessing a unit positive charge, which is equal to 1.6 into 10 to the power minus 19 coulombs. So in case of electron, this charge is negative, whereas in case of proton, this charge is positive. And the weight of the proton is around 1.67 into 10 to the power minus 24 gram. So the relative mass of proton is approximately equal to 1.0073 atomic mass units. Similarly, neutron, which is present in the nucleus, is a neutral particle of an atom having mass very nearly equal to that of the protons. Its absolute mass is around 1.675 into 10 to the power minus 24 grams and has a relative mass of around 1.00867 atomic mass units. However, neutron has no charge. That's why this is a neutral particle. Also in this section we are learning about the isotopes, isobars and isotones. So let's see what these terms mean. So isotopes are the atoms of the same element which have the same atomic number but different mass number. So as an example, hydrogen has 3 isotopes. For example, protium, deuterium and tritium. So protium is represented by H11, while as the deuterium is represented by H1 and superscript 2, and the tritium is represented by H subscript 1 and superscript 3 respectively. So these are called as the isotopes of hydrogen. Similarly, let's have a look at the isobars. So isobars are the atoms of different elements which have the same mass number but different atomic number. So as an example, argon, potassium and calcium have different isobars. So for example, if we look at the argon, it has an atomic number of 18 and it has a mass number around 40, while as in case of potassium it has an atomic number of 19, while as the mass number is 40. And in case of calcium, you can see the atomic number is 20, whereas the mass number is again 40. So argon, potassium, calcium are all isobars because they have the same mass number but different atomic numbers. In a similar manner, the other term that's used in chemistry is the isotones. So isotones are the atoms of different elements which contain same number of neutrons. However, both the atomic numbers and the mass numbers are different for the isotones. So as an example, if we take carbon, nitrogen and oxygen, right? So carbon has an atomic number 6, while as it has a mass number of 14. Nitrogen has an atomic number of 7, while as it has a mass number of 15. And oxygen has an atomic number of 8, whereas the mass number is 16. So carbon, nitrogen and oxygen that we have mentioned here, they are all isotones. So this concludes our today's lecture. I hope that you understood these basic terms. In our next lecture, we'll study about the Rutherford's scattering experiment. Until then, take care of yourself. Bye.